All right, this is question 4 from homework 5A. It says, find all real and complex solutions for the following rational equation. If you have more than one solution, enter answers from smallest to largest. Okay, so what we have here is a problem that's going to take a little bit of working out. So on the left-hand side, we have, we're adding rational expressions together, and then it's set equal to another rational expression, and so we need to get a lot of common denominators, and then solve for x eventually will be our goal. So to start off, I'm just going to focus on the left-hand side. So I'm kind of going to ignore what's going on the right. I'm just going to focus on the left over here of simplifying this as much as possible. So the first thing I'm going to do is go ahead and factor anything that can be factored. This x squared minus 4 is difference of squares, so it's x plus 2, x minus 2. I could potentially take out like a negative 1 up here just because that looks a little funny, and I would have 4x plus 1. But that's all. So I see that there are no common denominators between this and this. So I'm going to have to do quite a bit of multiplication because in order to add these together, it's just like adding fractions, you have to have a common denominator. So what I need to do is I need to multiply this first one by x plus 2, x minus 2. However, to save myself some work, because what you would have to do is FOIL out x plus 2, x minus 2, which I already have the FOILed out version, which is right here. So I'm just going to go ahead and multiply. Because this has neither of those factors, I'm just going to multiply by x squared minus 4. And that'll make it a little bit easier because I can just distribute here. So I will end up with 3x squared minus 12 plus, because I'm getting a common denominator, I'm just going to go ahead and combine these. This side needs to be multiplied by x plus 3. And I'm just going to kind of ignore what I did up here and know that I have to FOIL this out because these are two binomials. Okay, so what I get is negative 4x times x will give me, I'm going to put this in parentheses and be careful here, negative 4x times x is negative 4x squared, negative, it's jumping around. Negative 4x times 3 is negative 12x. And then I have negative 1 times x, which is negative x. And the negative 1 times 3 is minus 3. And that is all over the common denominator that I just got, which is x plus 3, x plus 2, x minus 2. So now I can simplify this as much as possible. So I have 3x squared minus 4x squared, so that's going to give me a negative x squared. And then I have negative 12x minus x, which is going to give me a negative 13x. And then I have negative 12 minus 3, which is going to give me a negative 15. Okay. And then that's all over the same common denominator of x plus 3, x plus 2, x minus 2. All right, now that I have simplified that as much as I can, I'm going to go ahead and bring this down. So this is equal to 5x plus 6 over, and I want to actually factor out this bottom before I bring it down. So I'm looking for factors of 6 that add to 5. That's going to be x plus 3, x plus 2. Okay, so the good news here is that I do have a couple factors in common. I have an x plus 3 already, and I already have an x plus 2. So the only thing that I need to multiply this side by is this x minus 2. but once again, I'm going to have to do some FOILing. So I'm going to go ahead and do that kind of off to the side. So I have 5x times x. This is going to give me 5x squared, and then 5x times negative 2 is negative 10x. 6 times x is plus 6x, and then 6 times negative 2 is negative 12. Okay, so now that I have x plus 3, x plus 2, x minus 2, x plus 3, x plus 2, x minus 2, what I can do is multiply everything by those denominators, and they are just going to completely cancel out. So all I'm going to be left with now are these numerators. So I have negative x squared minus 13x minus 15 equals, and I can go ahead and simplify this, 5x squared, negative 10x plus 6x is negative 4x, and then minus 12. Okay, so now I want to get everything on the same side, and I want to keep my leading coefficient positive, so I'm going to move things over this way. So when I do that, I'm going to add this x squared. I'll actually just show that over here. I'm going to add x squared, I'm going to add 13x, and I'm going to add 15. And this is all going to give me 0 on this side. So I'm going to get 6x squared plus, this is 9x, and then over here I get plus 3. All right, so now that these are set equal to 0, I'm going to try and factor them. It looks like I do have a common factor of 3, so I'm going to go ahead and take that out. And meanwhile, I'm going to kind of switch this 0 over to this side. So I'm going to take out 3, and I'm left with 2x squared plus 3x plus 1. That's equal to 0. And then from here, I want to factor this if I can. So I'm looking for factors of 3 that add to 3. Seeing if I can factor that, factors of 2. 2 times 1 is 2 that add to 3. And yes, 2 and 1 will do that for me. So when I factor that out, I get 2x and x, and I'm able to do plus 1 and plus 1. So those factors should work out, equal 0, and then I can set each of these equal to 0 to solve. So I'm going to be left with, this won't give me any solution. I'm going to subtract 1 divided by 2, so I'm going to get negative 1/2, and here I'm going to get x equals negative 1. Okay. So when it's asking me to put these, that's the first part. We're solving it for x, and so those are the solutions I got, and I put them in order from least to greatest, negative 1, comma, negative 1/2. That was part 1. And then part 2 says, what values of x are not in the solution set? And so you might have overlooked this from the start, but remember in our domain, our values of x that are possible, denominators can cause problems because we cannot ever have, you cannot ever have a denominator equal to 0, because if you divide anything by 0, it's undefined. And so there's actually a hole on the graph at that point. So I want to go look back up in this original and see what values will not work. And so I see an x plus 3, so that means if I plug in negative 3, then this will become 0 and it will not work. So x cannot equal negative 3. Over here, x plus 2x minus 2, x cannot equal negative 2, and it cannot equal positive 2, because if I plug those in, this will become 0. 0 times something is 0. It will make this denominator 0. And then on this side, I have the same things, negative 3 and negative 2. So that's how I got my answers here. The values of x that are not in the solution set are negative 3, negative 2, and 2. All right, so that's it for that one.